Hi, now we are going to learn how to express Coulomb's law in vector form. In the previous video, I have explained in detail about Coulomb's law. Those who did not watch that video, please do watch and subscribe, and don't forget to click on the bell icon to get the latest notifications. Let's come back to the class. Coulomb's law states or explains about the electrostatic force between two stationary point charges, and this equation represents the Coulomb's law. F is equal to 1 by 4 pi epsilon 0 q1 q2 by r square. Since this force is a vector quantity, we can express Coulomb's law in vector form. As you can see in the given figure, O represent a reference point, or we can consider this as the origin. And in the green color, you can see two charges q1 and q2 are represented. And vector r1 is the position vector of q1 and vector r2 is the position vector of q2. Position vector means the vector which represents the position of charge with respect to origin. So here vector r1 represent the position of q1 from the origin O, and r2 vector r2 represent the position of charge q2 from the origin O. And the distance between two charges q1 and q2 are represented by vector r21. Here we consider, for a convenience, we consider the vector leading from 1 to 2, q1 to q2 as vector r21. The same way we can consider the vector leading from q2 to q1 as r12. So here vector r21 represent the distance between two charges q1 and q2, and that is equal to the difference between two position vectors, vector r2 minus vector r1. So let me write that once again. Vector r21 equal to vector r2 minus vector r1. r2 is the position vector of q2. r1 is the position vector of q1. So here we consider the vector leading from 1 to 2, or we can represent this by r12. Vector r12 means the vector will be leading from q2 to q1. So we can represent like this as vector r1 minus vector r2. So you can see this vector r12 will be equal and opposite to vector r21. So we can write vector r12. Vector r12 equal to negative vector r21, because r21 is vector r2 minus vector r1. r12 is vector r1 minus r2. Hope you understood. So vector r12 will be equal and opposite to vector r21. And in the given figure, force also represented. Here vector F12 means the force on Q1 due to the charge Q2, because both charges will exert force on each other. So vector F12 represent the force exerted on charge Q1 due to charge Q2. The same way F21 means the force exerted on charge Q2 due to charge Q1. Okay, so these also equal and opposite. Here these vectors, vector r12 equal to negative r21. Its magnitude, if we are considering the magnitude of these two vectors, it will be equal, because this negative will change as positive when we are taking the magnitude. So the magnitude of these two vectors will be equal. Hope you understood. And this is the Coulomb's law. Now it is not in a vector form. In order to convert this equation to vector form, we have to multiply this with a unit vector. So let's see the general form of a unit vector as unit vector A cap is equal to vector A by modulus vector A. So this is the general equation of unit vector. So here instead of R we have to consider these two, R21, R12. So these two vectors, unit vector, we can write as vector R21. Unit vector R21 will be in this same way we can express it as vector R21 by modulus R21. The same way this R12 can also represented as a unit vectors R12 cap equal to vector R12 by modulus vector R12. So this way we can represent R21 and R12 unit vectors. So now we got the unit vectors. Now let's rewrite the Coulomb's law equation. First let's see Coulomb's law, that is F21. F21. What is F21? F21 means force on charge Q2 due to Q1. So by considering this equation, we can write this as 1 by 4 pi epsilon naught Q1 Q2 by, instead of R we have to consider this unit vector R21. So R21 square into that unit vector R21 cap. So here we multiply the equation with the unit vector R21 cap. Now this is in the proper vector form. The same way we can represent F12. What is F12? The force on Q1 due to Q2. In order to write this, just interchange the suffixes. So we can write this as 1 by 4 pi epsilon 0 Q1 Q2 by, instead of R21 we have to write R12 square, and instead of this unit vector the unit vector will be R12 cap. So these are our equations. So here we expressed the Coulomb's law in vector form as vector F21 equal to 1 by 4 pi epsilon 0 Q1 Q2 by R21 square into R21 cap, and F12. In order to write this, just interchange the R suffixes. So 1 by 4 pi epsilon 0 Q1 Q2 by R12 square into R12 cap. And these two equations are valid for any sign of Q1 and Q2. This Q1 and Q2 can be both positive, both negative, or it can be of opposite signs. So let's see one more figure. Here you can see in figure B the first one. That is Q1 and Q2 are represented here. Here the product of charges Q1 and Q2 greater than 0 means these are like charges. Both can be positive or both can be negative. Then the product will be greater than 0. At that case, the force between two charges will be repulsive. So you can see F12 and F21 directions. Both are of opposite directions, you can see. So this first case is for repulsive, and the second figure you can see Q1 and Q2. Here the product of Q1 and Q2 will be less than 0, means these two are unlike charges. One is positive, another is negative. So you can see the direction of F12 and F21. These are towards each other, you can see. Means here this represent attractive force. Hope you understand this topic well. Um, and one more thing we can write as F12. Let's see here. F12 equal to negative F21, isn't it? F21 is equal to negative F21. Both are equal and opposite. So we can say Coulomb's law agrees with Newton's third law. Hope you understand this well. Otherwise, please watch from the beginning. Thank you.